This is Mahesh Bhargav from CDAC Pune. First, I would like to thank you for OpenSSC and other stakeholders for providing opportunity to deliver the NLP and speech technology work that we are doing in CDAC. Here, I'm going to deliver talk on empowerment of cutting-edge speech technology by natural language processing. The talk is arranged in such a way, I'm going to give some overview, introduction, certain applications that we are working, and there are the area where the lot of scope is there, speech technology and live demonstrations if permits. So before moving to the presentation, let me tell you some brief about the CDAC is again a Center for Development of Advanced Computing. The vision of CDAC is very prominent that emerging as a R&D institution for design, development and deliver the world-class ICT solutions. We have a good team of 3,000 people of tech-savvy people, 12 locations, and establishment was happened in 1988. And these are the technical expertise domain that we have. So high performance CDAC is the main identity comes from the high performance computing and supercomputing, AI, multilingual, microprocessor, software technologies, education and training, and also adding the quantum is also be the one of the forte of the CDAC. So here I'm going to talk about the government initiative in the line of NLP and speech, and also for the machine translation and also the supercomputing environment. So the very first is the natural language translation mission. It is started and it was launched by our Prime Minister Narendra Modi in the Bhasini platform. The few things that I want to highlight over here is the NLP machine translation, create an ecosystem, open source data set and contribution. There is a need for creating this type of national mission translation. Because of that, the Indian languages have very few data sets and very few applications also. So this is the very great initiative taken by the government of India and our ministry MIT, where they are supporting to build such a large ecosystem as well as the data set for creating a various application to the need of all the Indians. And at the same, the journey will be continued for the NACM National Supercomputing Mission, where we get to deliver many supercomputer across the India, A-class institutions, research labs. And we are fortunate that we have a Param Siddhi, which is again equipped with the latest DGX A100 GPU cards that we are using this in our lab, and we are building the solutions using these humongous compute resources. So from now onwards, I'm talking about the more of the natural language processing. It's everyone is known about the lot of things. Humans, everyone communicate, and the communication mode of required the language. If you're going to see the how the language will be there, so it's a language, alphabets, it's made of alphabets, words, sentence, and the grammar. These are the essential things required to build and understand the language. So across the globe, more than 7,000 plus languages are spoken and understand. And also there are the languages where they are mostly on the vocational part. There will be no script for that also. So since the NLP is actually the tools or technology that can be used for, especially used for the data set. I mean, and you know that due to this social media world or tech savvy world, a huge amount of data and mostly the unstructured data is generated every day. And to cater and to generate the insights of this data set, we definitely require some technology. And the text mining process is also very essential for incurring information inside the text. So the India is we are fortunate that we have a 22 official language and 1.3 billion peoples, and the requirement are huge. The good thing is that from coming last few decades, the internet is ruling to the rural area and reaching to all the peoples. People are using mobile phones. Then definitely they require the information in their own language. Then the NLP and the speech technologies comes in the pictures, where we can provide various application through the voice interface. And definitely these are the promising areas. Natural language processing, it's a subfield of the computer science where we deal with the human language interactions. There's a various application involved in this technique. There is a sentiment analysis, chatbot, conversational AI. Is now the future is the conversational AI, where it's going to be replaced with the traditional chatbot and other systems, machine translations, spell checking, information extraction. These are the few list over here. There's a many applications can be visualized over there. So I just take a few minutes to tell you about the NLP, what are the process involved, and then what we are exactly doing. So these are the language processing steps. Definitely the phonetics where they actually deal with the sounds. Phonology is again it's a combination of sound where the phonemes, syllables, and all those will comes in the pictures. Morphology deals with the language words, syntax, semantics, pragmatics. All these are the some basic jargons we'll use for the language processing side. Component of NLP, morphologic analyzers, synthetic analyzers, semantic analyzers, pragmatic analysis. So these are the component that will be taking place if you're going to work on the NLP side. If you want to build some semantic analysis, you want to build machine translation. So these things will definitely comes in the picture to deal with that. But obvious the dealing with this type of data is again is challenging, and a lot of ambiguities will arise. There's a lexical ambiguities where what we want. A fisherman went to bank, and which bank is asking, it's a financial bank or is the river bank. So this logics can be come out with using the NLP techniques. So these are the techniques that evolve that will use while dealing with the textual part. There's a tokenization, stemming, lemmizations, POS, and so on and so forth. So what tokenizes? If your sentence, then we are break down in the white space form so that it will be available a discrete word over there. After getting that, we need to be go to the word root level. So it's going to be the root is the fish or fishing. So lemmatizing is just going to the actually the stemming and lemmatizing are somehow the complement each other. The parts of a speech explain how a word is used in the sentence. Main part of the speech, noun, pronoun, and it's just taking the words according to their grammatical rules and all these things. So usually across the globe, the pen areas text set will be used for tagging the words. At the same time that how you're taking the dog killed this, it's a DT, it's a determination, it's a noun, it's verb, and all this type of tagging will be this will give more insight of how the word will dealing in the sentence and how the meaning will be coming out of that. So this is again name entity recognitions where actually we have to tag each and every word key. It belongs to what it's an organization, it's a person, it's a location. The various application can be seen for this type of techniques. Chunking is again it's a useful thing. So now onwards, I'm going to talk about the speech technology part. Speech technology is design and recognize and synthesize human voice for making more world accessible. Definitely and due to the AI driven application is going to be the main modality of digital inclusion. So this is the actually frontier technology where the human can directly interact with using this technology. So this is the history of the technology from digits to the long sentences, from word, phonemes, syllables. So this is how the path of speech technology grow in almost 3 to 4 decades. It is speech technology, or I can say speech recognition is the interdisciplinary field of natural language processing, digital signal processing, AI, and DML. In any form, these pillars will be used to build the application and the technology. So here I'm just going to tell you how different approaches will be taking place for building this technology. It's speech is this is that. It's a traditional statistical based applications, and these are the different types of classification: speaker dependent, identifications, isolated, very small vocabulary size. These are the performance evaluation techniques, as a word error rate. These are the next. Now where we are actually, we started with the what data set in the real time data sets. We are getting almost human level accuracy or building this type of things. There are various difficulties involving in dealing with this type of speech data set. It's a real-time full display speech corpus. Again, it's a big data set, essential data set required for building the applications, speech corpus front end. So these are the modules that involve in building the statistical based speech recognition. Also, the speech processing, there's a capturing, PCM, silence removal. These are the front end feature extraction part, where the male abstraction coefficient will be extracted as a features from the signals. And after that, we will be able to build the acoustic model, pronunciation dictionary, language, and that will be input for the decoder. So this is how the statistical techniques we'll use for building the speech recognition. Now the trend is changed. Now it's a hybrid, and the end-to-end system will taking place once the deep learning will comes into the picture. Definitely it's overpass the HMM and GMM based techniques. The thing is that if you have more data, then it's difficult for the HMM and GMMs to deal with and getting the insight of that. Then the deep learning will comes in the picture. You can pump as many as hours of data. You will infer and you will get the output accordingly. So these are the various topologies and network will use for this building this one. There's a deep feed for convolutional RNN and also this. So these are the thing. I'm skipping some of the slides. This is again, it's a hybrid based system where at the same time, the DNN and the statistical approach will use to build the system. Now the scenarios comes for the end-to-end automatic speech recognitions where the signal will directly go for the CNN network, and it will be got for the caustic model and the language model. The entire pipeline is work for the neural network based deep learning approaches. So recently we have done so many experiments, and we have built Hindi, English, and Marathi and other languages speech recognition while using the few open source and NEMO based techniques. That is the coordinates is again it's an end-to-end neural network where there's a combination of the convolutional neural network and the CTC base. To perform this, we did series of experiments where we get the good promising word error rate where the accuracy is very high, but there are certain limitations also with that. We tried with the other recipe, that the citrinate. This is compared to the coordinate, this is very efficient and fast. Also it is the parameters is also very less if you compare to the previous ones, where we can get the byte pair encoding. We can treat here is the contextual information we can also target in this citrinates, which is giving promising results compared to the coordinates. These are the validation laws that we are getting over there. For Hindi, it's a 4.9, which is very promising. And also these all experiments we run on the Param Siddhi A100 GPU cards. The latest experiment we are doing with the conformer, which is again the combinations of the convolutional neural network, transformer, and the CTC network. CTC is the loss function that we are still how far your inference with that your data set. So these are the results that we various different types of network we have tested with the configuration with the hyperparameter we have set, and we got good accuracy over that. And for doing this experiment, definitely we use this toolkit Nemo, Riva, and Kaldi. Riva is again it's a framework developed by the NVIDIA. So here are the experiments, and we are able to get the good results also. So it's a Riva, it's a framework for multimodal conversational AI. And nowadays we are also able to developing the conversational AI systems for the various sectors so that we can get good output out of that. And the applications can be from the telecom domain, and the health sectors can be target over here. And some strategic sectors also in our list to develop the things. In the same line, we have developed certain application that's a Shrutikon Advanced, which is again the Hindi, English, and Marathi end-to-end speech recognition systems, which is available in the both web as well as mobile form. This is a Pravachak. Also, we do the speech synthesis part. This is a Mantra Rajbhasha system. It's a translation system. For the translation system will use for the upper house parliament. This is a Rajbhasha system. And the machine translation Kantas, this is again, it's a very promising application developed for the Department of Official Language. And this Anuvadak that we have done Indian language, English to Indian language machine translation systems. So this is how the EV, there is again, it's a sentiment analysis system that we build for the social media tracking test. It is also a very promising application that we used, build at in-house build, and the various language support is there, English, Hindi, Marathi, Gujarati. So this is how the actual things will be working over here. And this is a true set of output of the core NLP, and we are getting over here. So I think I'm done with my presentation. Thank you.